In today's video, we're gonna take a look at how we can turn this room into this. But before we continue, make sure you're subscribed to the channel and have the bell notification turned on. This helps the channel a lot. So what exactly is the plan? We're first going to generate 3D scan of the room, then build the clean model, add windows, furniture, model custom elements and make some cool images at the end. By the way, if you want to see the full process, I have made a paid video for that. The video features about 10 hours of work with live commentary and it includes the project files too. The link is in the video description. So let's start with making the 3D scan. First, I cleaned up the room so the scan would turn out a bit better, and quite quickly everything looked beautiful. Well, not in this room. I'm starting with the SiteScape app. It's the simpler one of the two options I'll show you today. You just move around the room, cover different angles and see the scan build in real time. It does a pretty good job at detecting glass, using the phone's LiDAR sensor. The downside is that it only creates a point mesh and the accuracy is not perfect. Also, it requires an iPhone Pro to use it. Now on to the second method, reality capture. While it also has a mobile version, I'm using it with the camera and PC software. I will take pictures as lot of different angles as possible so everything gets covered, and then later when I extract the 3D data, then we have the best result possible. The big advantage is that it can generate the full surface model, not just a point cloud. Here's an example I made for a friend. The room had a lot of detailed surfaces and the model turned out great. This made it easier for him to plan the apartment before construction. Another bonus is that the reality capture gives you the camera positions, which might be helpful if you need to build a 3D environment so you can see something through the windows. So what are the downsides of reality capture? It's more complex, it doesn't recognize glass, and flat surfaces without texture can be problematic. Something like painted walls, for example. Once both scans were done, I brought them into Blender, cleaned up the unnecessary parts, scaled them to the correct size and aligned them with each other, so I could use them as reference. And that brings us to the next step, building the clean model. For both of my 3D scans, I set the corner of the room as the origin. And that's also where I started building the clean model. I created a new plane, deleted 3 of its vertices, and moved the remaining one exactly to the scene origin. From there, I could start extruding the walls. I measured a few key dimensions with a tape measure, but for the most part, I worked based on the 3D scans. It didn't have to be millimeter accurate, because the goal was to test different ideas for the room layout. As I worked, I kept the model clean, deleting unnecessary edges and vertices, and making sure the normals were facing the right way. Next, I created the floor by duplicating the wall mesh, keeping only the bottom edges and filling in the faces. The ceiling was made by duplicating the floor and adjusting it to the right height. I also split the wall mesh into 2 parts, so I could easily hide one side when working from a specific angle. This is actually a great trick for rendering as well. It helps to avoid that distorted look when the camera is too close. I've used this method in a client project too, placing the camera outside the room boundaries to get the cleaner, more elegant look. And finally, I assigned materials to all the objects. Since the floor had a wood texture, I made a UV mapping for that. As for the windows, I had already modeled the windows for another project, so I just imported one and adjusted the vertices to fit the current window opening. I also did the same for the smaller window. For the baseboard, I used a photo of the existing trim as a reference. I started by extruding a simple profile shape from the side view, then gave it some thickness and beveled the edges where needed. For a cleaner result, I avoided using modifiers to wrap the baseboard around the room. Instead, I moved the vertices manually in edit mode. For the corners, I used the shear tool, and after that, I made another extrude now in the new direction along the next wall. When I needed to end the trim, I simply scaled the selected vertices to 0 on the corresponding axis. I also modeled the door, and with that, the clean model for the room was done. Now it was time to plan the room layout. The main idea was to make it work for my 13-year-old son, so the room needed space for PC gaming, studying, relaxing and sleeping. I started with the desk. It made sense to make it a bit bigger than the current one, and since the windowsill was already used as extra surface space, I figured why not extend the desk into that area too, creating an L-shaped design. Most of the assets that I didn't model myself came from Blender Kit. I added an acoustic panel with diagonal wooden slats to the wall next to the desk. It follows the slope of the ceiling and also helps with sound absorption. Under the smaller window, I placed a small fold-out sofa, bookshelves and matching acoustic panel like the one by the desk. On the opposite wall, I added a TV with a PlayStation. In the end, I was pretty happy with how this 5 square meter room came together. While building the room, I also created a lighting controller panel. The idea was simple. With one click, I can switch between day and night time. I used drivers to connect the lights, scene exposure and other elements into a working system. This way, both day and night setups are kept in the same scene. So, if I move furniture or change anything in the scene, it updates in both versions automatically. If you want to see how I put everything together for the full scene, you can follow the whole process in the paid video. For interior renders, especially for real estate, you usually want the vertical lines to be straight. To do that, place the camera right in the middle, between the floor and ceiling, and set the tilt angle to exactly 90 degrees. If you want to adjust the framing up or down, just use the Shift Y property in the camera options. Of course, you can break this rule at any time, because you don't want to be limited in your creative work. And now it is time to check out the final result. But before that, a quick reminder to like the video, subscribe, and any kind of support for the channel is really appreciated. Also, while the Patreon is still in early stages, I've added the room model as a free download, so you can test your own design ideas. Alright, let's take a look at the final renders.